Hello and welcome to your second micro lecture regarding the LC3's microsequencer. This is part 2 of my two-part video series designed to give you a crash course in all things related to the microsequencer component. This video covers how to apply your knowledge from part 1 to the LC3 state diagram. If you have not watched part 1, I strongly recommend you go back and watch that video before proceeding. Let's begin. We will begin by covering the special case of when your IRD bit is set to 1. The one and only time this occurs is during the decode phase, also known as state 32 on the LC3 state diagram. For each of the other 51 possible states, IRD will always be set to 0. But now since IRD is set to 1, rather than use the J bits for the address of the next state, the microsequencer circuit will utilize the opcode of the control word. This allows the LC3 to transition from the decode state to one of 16 different states based on what instruction the LC3 is trying to perform. If you want to learn more about what these various states and instructions actually do, please see our other videos covering LC3 instructions. Now let's take a look at what this looks like using the microsequencer circuit. The IRD bit of 1 causes the 2-to-1 mux to bypass the J bits altogether. Now the address of the next state will be denoted by 2 zeros followed by the control word's opcode. Now let's take a look at an example that actually utilizes the J bits. Here I have selected a state transition at random. Since this video isn't about LC3 instructions, I am not concerned with what these two states are or what they are trying to do. I am only concerned with the condition used to trigger the state change. In this case, the transition from state 28 back to state 28, as well as the transition from state 28 to state 30, requires a particular R value. For the state transition from state 28 to state 32, we see that we need an R value of 1. However, if we want to remain in state 28 and transition back to itself, we would require an R value of 0. Again, let's see what this looks like in the microsequencer circuit. Since the IRD is set to 0, we're using the J bits to determine the address of the next state. The state I picked at random was number 28. We can represent that value using the J bits as shown. As a reminder, here are the decimal representations of the binary J bits. So how do we transition to state number 30? The state diagram tells us that we need to set the R bit to 1. So let's focus on the part of the circuit that uses the R bit. In order to change the R bit, the condition codes need to be set to 001. In order to change to state number 30, we need to change the J of 1 bit to 1. We know this not only because the state diagram told us to set the R bit to 1, but just think about the difference between 30 and 28. We are trying to add 2 to our state number. In terms of the binary J bits, this means changing the second to least most significant bit, aka J of 1, to 1. So now what if we wanted to remain in state 28? We don't want any of the J bits to change. Since this transition is dependent on the R bit, we know that the condition codes must again be set to 001. Just as the state diagram says, we need to set the R bit to 0. By setting R to 0, the corresponding AND gate will output a 0, causing the corresponding OR gate to output a 0 and keep the J of 1 bit equal to 0. Now let's say that we are at state 30. According to the state diagram, there is only one possible transition away from this state. There are two things different about this transition from previous examples. For one thing, the diagram doesn't specify the bit used to perform the transition. Also, the state number is going down from 30 to 18. Let's try and figure out what's going on here. There are two key concepts you need to understand to make sense of a transition like this. For one thing, remember that the J bits being passed into the OR gate do not correspond to the address of the current state, but rather the next state. Because of this, it is entirely possible for a state to transition to a state with a lower state number. There are cases where the J bits could be the same for both the current and the next state, However, you shouldn't necessarily count on that happening all the time. And what about the state transition not specifying a bit to change? If the transition is left blank, like it was in this case, you can assume that the condition codes are set to 0 and no changes were made to the J bits. I hope you found this video informative and were able to expand your knowledge of the LC3 microsequencer. If you are interested in learning more about LC3, please see our other micro lecture videos. Thank you for watching.